All right, so just like you can have weak acids, you can have weak bases. So we can have some generic base B here interacting with water. It's gonna accept that proton. So H, it'll become Hb plus hydroxide, and then we can write an equilibrium for it, right? So this will be Kb because of base, right? And so this will be equal to the concentration of BH plus times that of hydroxide, and then times the concentration of B. And then, of course, you can also calculate a pKb. It will be the negative log of Kb. So kind of the same thing that we did with acids, just now with bases, right? So remember, as Kb increases, you get more hydroxides, and pKb will decrease. And both of these things mean a stronger base. So same story as with the acids. Now we're just talking about bases. And so the problems are very similar. The one thing you kind of want to pay attention to is the R in the Rice table. And that's these equations. Oftentimes for weak bases, you need to include water in your equation, or you won't be able to make the equation make sense. So for acid, we can write just HA goes into H plus A minus, but let's take a look at a base, right? We have NH3, ammonia is a weak base. And so if you don't include water, it gets very confusing as to how this is gonna react. So you need to include water, right? It's gonna steal a proton from the water, so it'll be NH4 plus hydroxide, right? And so there's your concentration of hydroxide, which you can then use to find Kb and whatnot. We'll talk about this a little bit later on, but you can see any nitrogen-containing component is usually a base. So if you see a nitrogen and it has a lone pair, it's most often a base. And if you think about it, it makes sense that you would need a lone pair for something to become a base, because what you're doing is you're grabbing an H plus by forming some sort of bond. So let's just draw that really quick here. So we have NH3, and this lone pair, what it's going to do, it's going to attack this H on this water, and the electrons in this bond are going to kick off to the water to form our final product, right? So these are called arrow pushing diagrams. You'll learn a lot more about this when you get to organic chemistry if you're taking that course. And same thing here, this nitrogen picks up this H, the electrons in the bond go to the oxygen, and then you get the product. Here's an example. Oops, nope, I just copied that picture. So here's just an example of some weak bases. You'll see that a lot of them have a neutral nitrogen, which means that it has a lone pair in it. And so that's kind of, that's where that base comes from. And then another way to really see bases is that they're conjugate bases of weak acids, right? So carbonic acid is a weak acid. So bicarbonate and carbonate can be bases. We'll learn more about how to spot whether something is an acid or a base a little bit later on. And then there's a whole bunch of, we can do the same pH, POH, pKa, pKb, Ka, Kb questions that we did for the acids, for the bases. And so the questions are all the same, right? You're going to do a Rice table, except now you're talking about a base instead of an acid. So really look in your book, 14.9 through 14.4. You want to go through those examples and make sure you understand why they're doing what they're doing.